In section 4, we're going to be looking at linear equations in two variables. We've done a little bit of that already, but we're going to be talking specifically about slope, about how do we calculate slope, how do we use slope to graph equations, how can we write equations given supplied information, how can we use the slope to help us identify parallel and perpendicular lines, and then how can we use slope and linear equations to model and solve problems. So information that you should already sort of remember is our typical equation that we're working with is called slope-intercept form. And it's called slope-intercept form because it shows the slope, m, and the intercept, the y-intercept, b. So when we're looking at y equals mx plus b, it's very useful to us as a form because it shows us the slope and the y-intercept, which are typically used for graphing. So the simplest mathematical model for relating two variables is the linear equation in two variables, which is what we were just talking about, y equals mx plus b. And it's called linear because its graph is a line. So when we start talking about slope, if we typically look at slope moving from left to right. So generally what we're saying is as we go from left to right, what does the slope do? A positive slope will trend upwards from left to right. On the other hand, a negative slope as we move from left to right will trend downward. So this one is moving up and this one is moving down. Okay, so positive slope, negative slope. If we had a horizontal slope, that would be a slope of 0. And in this special case, for a vertical line, the slope is undefined. And as we go into the calculation for slope, it'll become kind of clear why vertical lines always have an undefined slope. First off, you could think of the slope as infinity, but it's not that, it's actually undefined. So if we want to graph a linear equation when we're in slope-intercept form, typically what we want to do is we want to find the y-intercept and place it on the graph, 1, 2, right there. And then I would move by slope, in this case -3, so I have a negative slope. And when we're talking about moving slope, we're going to move a combination of rise over run, meaning vertical change to horizontal change, that would equal this slope, which would be -3. So if I went down 3, 1, 2, 3, that's -3, and right 1, -3, right, -3 divided by 1, down 3, right 1, that's a slope of -3. Equally, I could go up 1, 2, 3, and left 1. That would be 3 over -1. That equals -3. Right? Either way I go, once I have 2 points, that will have determined my line, and then this is graphing the line. Okay, so I missed a little bit. Let me put it back where it belongs. And there's our line. If we look at this, y is equal to -3. Well, if all of my y values are -3, so it doesn't matter what x is, y is -3, that's what it looks like when we have a horizontal line. And now it has a slope of 0, so you'll notice that when y is equal to 0x minus 3, that just simplifies to be y is equal to -3. When my slope is 0, this is what I get. Okay, in this case, if I wanted to try to start picking out things like slope and y-intercept, I want to put it in y equals mx plus b form. So in that case, I would subtract 4x. I have a y-intercept of 5 and a slope of -4. 1, 2, 3, 4, 5 is my y-intercept. I will go down 4 and right 1. That will be a slope of -4. And there's my line. Okay, if we want to calculate slope, I mentioned earlier that slope is rise over run. So how do we calculate rise? So if I find that slope is equal to rise divided by run. Rise is vertical change, and vertical change, as I move from point to point, vertical change could be measured by taking the y value of the second point minus the y value of the first point, y2 minus y1. That would equal the rise. And the run is the horizontal change, and that can be calculated by finding the difference between the x-coordinate of the second point and the x-coordinate of the first point, x2 minus x1. So and that's where we get this equation down here, that slope is equal to y2 minus y1, rise, divided by x2 minus x1, run, or rise over run. And if you look down below, it doesn't make any difference which point you care to make first, as long as you're matching which point you're calling your first point and which you're calling your second point. So it doesn't make any difference how you go about it. The only way you can screw yourself up a little bit or get yourself crossed up is when you make one point the first point in rise and make a different point the first point in run. All right, so this was okay, but here we got all crossed up, and that's not going to work out. Okay, so this is the only real mistake you can make. Either way, which point you decide to put first in this equation doesn't make any difference, as long as you keep the x and y values matched up to each other. If I want to go ahead and calculate slope, that's pretty simple. Again, I just have to determine which point I'm going to use first. So I'm going to do, in this case, I'll use 8 minus negative 6, and 2 minus negative 5. 8 minus negative 6 is 14. 2 minus negative 5 is going to be 7. So this would be a slope of 2. Here I'm going to do 5 minus 2, that's 3. And 2 minus 4, that's negative 2. So my slope would be negative 3/2. In problem C, I'll do negative 6 minus 0. That's negative 6. And I'll do 0 minus 0, and that's 0. And this is a problem. I can't have a fraction with a denominator of 0. So this becomes undefined. And this is what it looks like when you try to find the slope of a vertical line, because there is no run. The x-coordinate in the first, if I thought about graphing these really quick, I'd be at 0, 0, and 0, negative 6. This is a vertical line. Right? When I try to find the run, there is no run, and that puts 0 in the denominator of my fraction, and I can't have that. Okay? Continuing on, negative 1 minus negative 1 is 0. 3 minus 0 is 3. 0 over 3, this is a slope of 0. This is a horizontal line. Right? So this one here would be vertical. And this one here would be horizontal. It depends where the 0 ends up. If it's in the numerator, it's horizontal. If it's in the denominator, it's undefined, and that's vertical. Okay, if we want to write the equations of linear functions, what we need to find the slope and a point. And consequently, this is called point slope. This form is called point slope. Okay, that's sort of the minimum we need to have. So in this case, they've given me slope and a point, and I want to write this out. Y is simply y, right, because I'm going to have y. when I have y equals mx plus b, but the y sub 1, that's the y from the point. My slope is 2, and I'll have x is x, and the x sub 1 is the x from the point. Right? So when I simplify this, I'll get y plus 7 is equal to 2x minus 6. And when I subtract 7 from either side, y is equal to 2x minus 13. And that's my linear equation. In this case, same idea. I just happen to have a slope that's negative, and it also is a fraction, but I'm still going to use y minus the point, the y coordinate from the point, is equal to the slope, negative 2/3, times x minus the x coordinate from the point. So y minus 1 is equal to negative 2/3 x plus 2/3. And when I add 1 to either side, I'll have negative 2/3 x, and I add 2/3 plus 1, which is 3/3, so it would be plus 5/3. And that's my equation. Okay, we can use slope to help us identify parallel and perpendicular lines because the slopes of parallel lines are equal to each other, and that helps me out. Okay, so I know if I'm trying to find the equation of a line that is parallel to my original line, then I know that their slopes will be equal to each other. And similarly, I know that lines are perpendicular if their slopes are negative reciprocals of each other. Okay, so I would use either of these formulas to help me out. Then all I would need, if I knew how to find the slope, would be a point, and then I can use the point-slope formula. So let's take a look at what that looks like. Here they're asking me to find the slope-intercept form of the equations of the lines that pass through the point. There's my point, and are parallel to and perpendicular to, so I'm going to do this 2 times, this other line. So the first thing I want to do with this line here is I want to put it into slope-intercept form. So I'm going to add 3y and subtract 8. And then divide by 3. So y will be equal to 5/3 x minus 8/3. That's the equation of the original line. Now in the first part, I know that my line is parallel to that, so I know that my slope will be equal to the same slope because the slopes of parallel lines are equal, and then my point will be negative 4, 1, and I can use point slope. So y minus 1 would be equal to 5/3 times x minus negative 4, that's x plus 4. So y minus 1 is equal to 5/3 x plus 5/3 times 4 is 20/3. And when I add 1 to either side, y would be equal to 5/3 x plus 20/3 plus 1, which is 3/3. 20/3 plus 3/3 is 23/3. And that's my line. Now in the B part of the problem, my slopes are a little different. I know that my slope will be equal to negative 1 divided by the other slope. So here the slopes are equal, and here I have to find the negative reciprocal, which can be found just by inverting it and multiplying it times negative 1. I'm using the same point, so I'm going to have y minus 1 is equal to negative 3/5 times x plus 4. So the 1 and the negative 4 didn't change. Now when I go ahead and complete this, I'll have y minus 1 is equal to negative 3/5 x minus, in this case, 12/5. 4 times 3/5 is 12/5. And when I add 1, which will be 5/5, y will be equal to negative 3/5 x, sorry, negative 3/5 x. And it's going to be minus 12/5 plus 5/5 is going to be minus 7/5. And there is my equation for my perpendicular line. So you notice the slopes are the same. The slopes are negative reciprocals. And then because the slope and everything changed, so did the y-intercept. If I wanted to apply this information, in this case we're going to look at using slope as a ratio. They're saying the maximum recommended slope of a wheelchair ramp is 1/12. So that would be a rise of 1 over a run of 12, right? This is what it would look like. A business is installing a wheelchair ramp that raises 22 inches over a horizontal length of 24 feet. Oh my. Is the ramp steeper than recommended? Well, here's my problem. I'm allowed to have a 1:12 ratio, but this is in inches, 22 inches, and this is in feet, so it's hard to compare them. Now what I could look at is I could say, well, what would 1/12 be? Just to answer their question. That means the maximum, if I had 24 feet, I could have 1/12 is equal to x over 24, excuse me. And in this case, x would be equal to 2. Right? So 2 feet would be the maximum height I could have. Is 22 inches greater than or less than 2 feet? Well, it's less than. So is the ramp steeper than recommended? No, it's not. If this was more than 24 inches, then it would be steeper than recommended. Okay, if we think about rate of change, an accounting firm determines the value in dollars of a copier T years after its purchase is modeled by this equation. So describe the practical significance of the y-intercept and the slope. Well, if you start to think about it, if t is time, when time is 0, right? So we have time and value. Those are our x's and y's. When time is 0, the value here would be 1,500. That means that's the value now. So let's see, 1, 2, 3, 4, 5. So let's just say each one of these is 300. So this is 3, 6, 9, 12, $1,500 right there. When I go to 1, I'll have negative 300 plus 1,500. That's 1,200. Okay, so that's 1,200. And when I go to 2, I'll have negative 600 plus 1,500, and that's 900. So what's happening is the 300 represents the amount of the loss in value each year. Okay, so the y-intercept is the original value. Its value in year 0. The starting situation. And the slope is the loss per year. The amount of value we lose each year. And if we were to graph this, this is what it would look like. And you could see that eventually it would have no value. Oops. Okay, so when we get to this particular year, 1, 2, 3, 4, 5, after losing $300 a year, it has no value. Okay, depreciation is also dealing with loss of value. There are many different types of depreciation. In this case, it's straight line, which follows a linear situation. A manufacturing firm purchased a machine worth $24,750. Okay, That's the original value. The machine has a useful life of 6 years. After 6 years, the machine will be discarded and replaced. That is, it will have no salvage value. Write a linear equation that describes the book value of the machine each year. Okay, so if we take a look at this information, they've given me enough information for 2 points. They have told me that in the first year, year 0, the value of my machine is $24,750. And they've told me that at the 6th year, in 6 years, the machine has no value, 0. All right, so if we wanted then to write the equation, we need a point and the slope. Well, we have enough to write the slope. So 0 minus 24,750 is negative 24,750. And 6 minus 0 is 6. Okay, so I might want to simplify that. Let me go ahead and pull out a calculator. So if we have 24,750 divided by 6 is 412.5. So I'm going to use that as the slope. And then if I put everything into the point slope form, right, I know that y minus 24,750 is equal to my slope, 412.5, times x minus 0. So you might ask, why did I choose this point? Could I have used this point? Sure I could. Absolutely. It wouldn't have made any difference if I had used this point. It all would have been fine. I just did it because I didn't want to multiply 412.5 times 6. By putting it over here, I didn't have to do that multiplication. If I add 24,750 to either side, y is equal to 512.5x plus 24,750. And again, what do these things represent? Sorry, negative 412.5. What do these things represent? This is the original value, and it loses $412.50 in value each individual year. Okay, now we can also use linear equations for predicting sales. That can happen often. In this case, we've got data for 2009 and 2010. We want to predict sales in 2013. So again, they've given me points, okay, if that makes sense. So what I can do, however, is maybe I don't want to work with X being 2009 or 2010 or 2013. I could call 2009 year 0, which makes 2010 year 1, and it makes 2013 year 4. I'm just going to be working on years since 2009. So I've got a couple of points here. I've got 0, 58.6 billion, and I've got 1, 56.6 billion, and I can calculate slope. Then I'll pick a point and I'll write the equation. Okay, then we'll move along and do something else. So my slope will be 56.6 minus 58.6 over 1 minus 0. Well, this is going to be 2, negative 2, over 1, which is negative 2. That's nice. So my intimidating numbers are all gone. I'm going to again go ahead and pick this first point, y minus 58.6 is equal to negative 2 times x minus 0. And when I add 58.6 to either side, y is equal to negative 2x plus 58.6. Okay, so write a linear equation. I've done that. Then predict sales in 2013. So that means I have to do something else. So this is year 4. If I plug 4 in for x, I should be able to find the sales. So it'd be -2 times 4 plus 58.6. This becomes -8 plus 58.6. So my prediction is that the sales for 2013 are equal to 50.6 billion. Okay, keep an eye out for this word then when you're working, especially if you're working on a test. This tells me to do one thing, that's part A, and then do something else, that's part B. That means there are 2 answers. So just a quick summary, things we've talked about. We've got standard form or general form of a linear equation. We've got the form of a vertical line, x is equal to 0. Form of a horizontal line, I'm sorry, not x is equal to 0, x is equal to a, some number, right? The horizontal line, y is equal to b. It's called b because it would be the y-intercept in that case. We have slope-intercept form where we have m is slope and b is the y-intercept. We have point-slope form, y minus y1 equals m times x minus x1. And we have 2-point form. I didn't use this in the lecture. Instead, I did this part separately, and I calculated slope and then used point slope. If you wanted to do it all as one thing, you could do that and use 2-point form. And one thing that can happen is when we use our line to predict something that happens outside of our known information. That's what we did in this last problem, right? They told me the sales for 2009 and 2010 and wanted me to predict what would happen in 2013. That looks like this. They gave me these points, and they want me to predict what's happening out here beyond the points. That's called extrapolation. I'm going outside my poles. Okay? On the other hand, they might work with, we did some problems with midpoint in the previous section where they gave me 2 values and I wanted to estimate a value in between the 2 values. So when it's between my poles, it's called interpolation. Okay, and a summary of the things that we did in this section. We went through using slope to graph a linear equation in 2 variables, calculating the slope of a line passing through 2 points. We created the point-slope form of the equation of a line, and we used it in order to write the equations of line in slope-intercept form. We also used slope to identify parallel and perpendicular lines and write those equations. And then we used slope and linear equations to model and solve real-life problems.